Hello friends, we're going to solve some more rational equations. So here we're starting with a rational equation and we have some basic steps that will always work through the problem. The first thing we always want to do is we want to factor any of the denominators if possible because we're going to try and determine an LCD. And if you notice, this last piece of the fraction here is a difference of squares. So I'm going to want to factor that before I can consider finding my LCD. So in this case, I'm really dealing with this problem. X over x minus 4 over x plus 4 equals 32 over x plus 4 x minus 4. So in this situation, my LCD is actually x plus 4, x minus 4. If I hadn't factored this original denominator, I might also have written over here on the side of my LCD x squared minus 16. But I don't want that because that's going to make my problem much larger in powers than I want to deal with. Okay, so we always want to make sure we factor first and then determine our LCD. So after we've factored, we found our LCD, we're going to multiply everything by the LCD to clear the fractions. So in this case, I have x plus 4, x minus 4, times x over x minus 4 minus x plus 4, x minus 4 times 4 over x plus 4 equals 32 over x plus 4, x minus 4 multiplied by x plus 4, x minus 4. And so what's going to go on here is that we're going to lose each one of these fraction pieces. They're going to lose their denominator. So I have x plus 4 times x minus x minus 4 times 4 equals 32. So we're going to continue solving this. I have x squared plus 4x minus 4x minus 16 equals 32. Now, I made a mistake here on purpose to point out, but what we need to make sure we notice is that this minus was in front of all of this. So this minus is still in front of all of this, and we need to make sure we've got parentheses in here because that's going to cause some distribution. So I have x squared plus 4x minus 4x plus 16 equals 32. Both of those 4x terms add to 0, so they disappear. X squared plus 16 equals 32. X squared equals 16. I subtract 16 from both sides. And I end up with x equals plus or minus the square root of 16. Make sure you note that when we use a square root to solve, you have to put plus or minus in the problem. So what we're ending up with here is x equals plus or minus 4, or rather two answers, x equals positive 4 and negative 4. And we go, oh yay, we are all done. How fantastic. But are we? So what we need to ask ourselves is, do these answers check? You always want to ask yourself if the answers check. So if we go back up to the original problem and we look at what would happen if we put positive 4 or -4 into the problem, we would end up in both situations with a 0 in the denominator. So, because we can't plug either of those in, there's no solution. And in this case, we would consider both of those answers were extraneous. All right, and here we have another rational equation to solve. 3 divided by m plus 2 plus 2 divided by m equals 4m minus 4 divided by m squared minus 4. And so just as we did on the last problem, we're going to make sure that we factor our denominators before we try to find our LCD. And the first two terms, the denominators don't factor, but on that last term, we again have a difference of squares. So I've got m plus 2 and m minus 2. So in this situation, my LCD is m plus 2, and m minus 2. So I'll multiply each term by that LCD. So the first term, 3 over m multiplied by the LCD, plus 2 over m. The next term, multiplied by the LCD. And my last term here, and I'm running out of space, so I'm going to write it kind of up the edge. So what happens is I lose a denominator and some factors on each of these. This leaves me with 3m, m minus 2, plus 2, m plus 2, m minus 2, equals 4m minus 4, all of which is still multiplied by that last little piece right here that we've got left. These two crossed out, and we've got an m left. So now we're dealing with an equation that we need to solve. I'm going to start distributing. I've got 3m squared minus 6m plus 2, multiplying here. I've got m squared minus 4. I'll distribute the 2 in a second. And then my term on the right side, when I multiply, I'm going to get 2 pieces, which would be 4m squared minus 4m. So one more step. Distributing that 2. And we have this equation, and we need to say, well, what kind of equation are we dealing with? Because we're still trying to solve it. And we started with something that was rational, but we've manipulated it to make it easier for us to deal with and easier for us to solve. And when we come in here and we look and we notice that we've got some m squared terms, what that means to us is that it's quadratic. And if it's quadratic, we want it in that descending order, ax squared plus bx plus c equal to 0. So as soon as we notice it's quadratic, we want to get it into that standard form. So rearranging this, I've got some like terms on the right that I can, on the left that I can combine. I've got 5m squared minus 6m minus 8 equals 4m squared minus 4m. I'm going to subtract 4m squared from both sides. I've got m squared minus 6m minus 8 equals negative 4m. And then I would add 4m to both sides. And running through this, I end up, I've got now m squared minus 2m minus 8 equals 0. So now I've got it as a quadratic equation in standard form, descending order, equal to 0. And once I have it like this, I can factor it. And there are two numbers that can factor to give me negative 8 that will also add to give me negative 2. So this is m minus 4, m plus 2 equals 0. And by setting each of those factors equal to 0, I end up with m is positive 4 or negative 2. So m equals positive 4 and negative 2 are my two solutions, and I'm all done. So I put them in a box and go, yay. But what we have to remember and what we have to double check is, do both negative 4 and negative 2 work in the original domain of this problem? So remember, what we started with was 3 over m plus 2 plus 2 over m equals 4m minus 4 over m squared minus 4. And what's going to happen if I go and I plug negative 2 into my problem right here? If I plug negative 2 in, I'm going to get 0 in the denominator, which is undefined. So one part of our solution is extraneous. Only m equals positive 4 is the answer.